A light plane flies 450 miles with the wind in 3 hours. Flying back against the wind, the plane takes 5 hours to make the trip. What was the rate of the plane in still air? What was the rate of the wind? Now, the first step of completing any word problem is stating the variable and the unknowns that they represent. So notice here how I have stated that x will be the speed or the rate of the plane in still air, and then let's let y equal the speed or the rate of the wind. Now, as I read this problem, I notice that there are really 3 quantities at work here. I have a distance, I have time being given to me, and then there's a rate that's in question. So the distance equals rate times time formula will be a great asset to us as we work to solve this problem, which is exactly why I have created this chart here. Notice that the heading of each column represents distance, rate, and time. And then I have 2 rows. One row represents the trip of the plane with the wind, and the second row represents the plane of the trip against the wind. Now, in terms of filling out the chart, as I go back and read the first sentence, I notice that there are 2 values that are really kind of in my face. A light plane flies 450 miles with the wind in 3 hours implies that the time is 3 hours and the distance is 450 miles. So right off the bat, I can fill these 2 values into my chart. I'm going to go ahead and put a 3 underneath the time column for the trip going with the wind, and I'm going to put a 450 underneath the distance column. Now let's talk about the rate. When a plane flies with the wind, we assume that the plane will fly faster because the wind is working with the plane and it's kind of pushing it along. And so if we take the speed of the plane in still air and add the speed of the wind, we get a faster rate, and so we can say that the speed of the plane with the wind is represented by the expression x plus y. Now let's talk about the plane going against the wind. As I read this second sentence, flying back against the wind, the plane takes 5 hours to make the trip. Again, there are a couple of values that I can very easily fill into my chart. We are being told that the trip takes 5 hours, so I can fill a 5 in underneath the time column for that trip. And we can assume that the distance is the same because it's almost like the plane is flying with the wind one way, and then it turns around and flies against the wind the other way, and the distance is the same for each trip. Now let's talk about the rate. When the plane is flying against the wind, we assume that the rate of the plane is actually going to be slower than it would be in still air because the wind is working against the plane. So if we take the speed of the plane in still air and then subtract the speed of the wind, we get a slower rate, and so the rate of the plane going against the wind can be represented by the expression x minus y. Now, once we have completed the chart, we really have the 2 equations sitting here right in front of us that we need. The first equation that's based on this distance equals rate times time formula is 450 equals the rate, which is represented by the quantity x plus y, times 3. And the second equation is 450 equals the rate represented by the expression x minus y times 5. Now I'm going to go ahead and write these equations in a way that's going to make them a little bit easier for us to work with going forward. First of all, I'm going to distribute the 3, and then I'm going to flip this around a little bit. So I have 3x plus 3y equals 450, and then I'm going to do the same thing for the second equation. 5x minus 5y equals 450. Now, coming up with the 2 equations is often the most challenging part for most students. Once you are able to create the 2 equations that you need to solve the problem, you can solve the problem using whichever method you prefer. You can use the graphing method to solve this system. You can use the substitution method to solve this system, or you can use the elimination method. And that's the method that I'm going to go ahead and show in order to finish up this problem. So let's solve this system by elimination. I'm going to go ahead and multiply the first equation by 5 all the way through, and I'm going to multiply the second equation by 3 all the way through. And I'm going to do that in order for me to be able to eliminate the y variable. So if I multiply the first equation by 5, I get 15x plus 15y. And when I multiply 450 times 5, I get 2,250. Now I'm going to multiply the second equation through by 3, and I get 15x minus 15y. And when I multiply 450 by 3, I get a value of 1,350. Now I'm going to continue the elimination process by adding down. When I add 15x plus 15x, I get 30x. When I add 15y minus 15y, that variable is eliminated because that equals 0. And when I add 2,250 to 1,350, I get a result of 3,600. Now I'm going to solve this equation for x by dividing each piece by 30. And I get a result of x equals 120. Now if I go ahead and substitute the x equals 120 back into either one of these equations, for example, I'll just go ahead and stick the 120 for x back into the first equation. And I solve for y, I end up getting y equals 30. Now, let's go back to the original problem and make sense of these values. So remember that we let x equal the speed of the plane in still air, and we got a value for x equal to 120 miles per hour. So that answers the first question, that being what was the rate of the plane in still air. And then when we solved our system for y, we got a result of 30 miles per hour. And so that answers the second question of what was the rate of the wind.